Welcome to Deshpande Mathematics Academy. Now I discuss about very important concept in mathematics, that is calculus. In calculus, one of the most interesting concept is differentiation. Now I discuss about the concept differentiation, and it is also called differentiability. Okay. Now we start to understand the concept differentiation with an example. Let us consider a function y is equal to x square plus 1. In this function we put the value of x is equal to 1. Then the value of y becomes x square, means 1 square, plus 1 is equal to 1 plus 1, that is equal to 2. Suppose x changes to, or x changed from 1 to 1.1, then value of y is equal to 1.1 whole square plus 1, that is equal to 1.1 whole square is 1.21 plus 1 is equal to 1.21 plus 1 is equal to 2.21. Here increment value in the x increase in the value of x is increase in the value of x is 1.1 minus 1 is equal to 0.1. And similarly, corresponding change or increase in the value of y is 2.21 minus 2 is equal to 0.21. These small changes are called increments. These small changes in both x and y are called increments. The increment of x or the increment in x is denoted by delta x. Here increase in the value of x is 1.1 minus 1 is equal to 0.1. Therefore delta x is equal to 0.1. This is increment in x. Similarly, increment in y is denoted by delta y. That is 2.21 minus 2 is equal to 0.21. Now we calculate incrementary ratio, means delta y by delta x is equal to delta y is 0.21 divided by delta x is 0.1. 0.21 divided by 0.1 is equal to 2.1. Suppose x changed from or x changes to 1 to 0.1 to 0.9, then y is equal to x square means 0.9 whole square plus 1 is equal to 0.81 plus 1 is equal to 1.81. Here increase or decrease in the value of x is delta x is equal to 0.9 minus 1 is equal to minus 0.1. Similarly, delta y is equal to here 1.81 minus 2 is equal to 1.81 minus 2 is equal to minus 0.19. Here incrementary ratio delta y by delta x is equal to minus 0.19 divided by minus 0.1 is equal to 1.9. Okay, look here. Here delta y by delta x is incrementary ratio. Here delta y by delta x is decrementary ratio, because here x changes to positively 1.1 to 1 to 1.1. 1 to 1.1. Here x changes to 1 to 0.9. 1 to 0.9. This is incrementary ratio, therefore this is decrementary ratio. These two results are here, delta x and delta y are decrements, because 0.9 minus 1 is equal to minus 0.1. Here delta y is equal to 1.81 minus 2 is equal to minus 0.19. These two results are negative. Therefore, these two results are decrements in both x and y. Therefore, delta y by delta x, here decrementary ratio is equal to 1.9. We think about, suppose delta x made sufficiently small, means delta x tends to 0. Delta x tends to 0 means very close to, very near to 0. Delta x is 0.1. Suppose we take delta x is equal to 0.00001 or 0.00001. Then value of delta y by delta x is near to 2.0001 means very close to 2. Similarly, here delta x is equal to minus 0.00001. Then delta y by delta x is equal to 1.999999 or 1.999981. These two results are, when delta x tends to 0, these two results are very close to, very near to 2. Very close to or near to 2. This value is called derivative of the function y, that is that y is equal to x square plus 1 at point x is equal to 1 is 2. Derivative of y, the curve derivative of the function y is equal to x square plus 1 at point x is equal to 1 is 2. Therefore, the derivative of the function y is equal to x square plus 1 at point x is equal to 1 is 2. What is the meaning of the derivative of the function y is equal to x square plus 1 at point x is equal to 1 is 2. This 2 is represents slope of the tangent to the curve y is equal to x square plus 1 at point 1. Now we are trying to this concept with graph. Look here. This is graph. In this graph, this is x-axis and this is y-axis. Line passing through the or cuts the y-axis at point 1 and parallel to x-axis. And the curve touches the line at point 1, then equation of this curve is y is equal to x square plus 1. Now we draw the tangent to the curve at point x is equal to 1. The slope of the tangent is equal to slope is equal to definition tan theta. Therefore that tan theta can be defined opposite side by adjacent side. Look here, in this triangle opposite side length is 2 units and adjacent side length is 1 unit. Therefore slope m is equal to 2 by 1 is equal to 2. The tangent touches the curve y is equal to x square plus 1 at point 1 comma 2 and passing through the origin. Therefore value of x is 1 unit and value of y coordinate is 2. Therefore m is equal to y by x means opposite side by adjacent side, that is 2 by 1 is equal to 2. Then we discuss about or generalize about the derivative concept because this is lengthy process. Therefore try to understand easily. Therefore generalize, it can be generalized as, look here, let us consider or a function. Let us consider a function y is equal to f of x. Suppose in this graph x changes to x plus delta x and corresponding change in y changes to y plus delta y. Then y is equal to f of x becomes, in place of y put y plus delta y is equal to f of, in place of x put x plus delta x. Then delta y is equal to f of x plus delta x minus y. Therefore delta y is equal to f of x plus delta x, take as it is, minus y. Already y is equal to f of x, therefore in place of y put f of x. We calculate delta y by delta x. Already we know that this is incrementary or decrementary ratio. Here only delta y is there. Therefore dividing by delta x both sides. Then delta y by delta x is equal to f of x plus delta x minus f of x whole divided by delta x. Now delta x made sufficiently small, means that delta x tends to 0. Therefore taking limit as delta x tends to 0, then both sides. Delta x tends to 0, both sides. Then limit as delta x tends to 0, delta y by delta x is equal to limit as delta x tends to 0, f of x plus delta x minus f of x whole divided by delta x. Limit as delta x tends to 0, delta y by delta x, delta y by delta x is denoted by dy by dx or f dash of x or d by dx of y. Therefore, dy by dx is equal to limit as delta x tends to 0, f of x plus delta x minus f of x whole divided by delta x, means limit as delta x tends to 0, delta y by delta x is denoted by dy by dx or f dash of x or d by dx of y. Therefore, in place of limit as delta x tends to 0, delta y by delta x, we use the notation dy by dx. Otherwise, use f dash of x or d by dx of y is equal to limit as, right side take as it is, limit as delta x tends to 0, f of x plus delta x minus f of x divided by delta x. The process of finding derivative of the function y is equal to f of x with respect to x using this formula is known as the finding derivative of the function y is equal to f of x with respect to x from first principle. Okay, now we are discuss about another one function, that is y is equal to k, means constant. This is constant function. Now we take y is equal to k. This is an equation number 1 or result number 1. Then suppose in this case x changes to x plus delta x, then y change to y cannot change because y is equal to k is a constant function. Therefore, y does not change. Assume that suppose y changes to y plus delta y. Then equation first becomes y plus delta y is equal to k. Now delta y is equal to k minus y is equal to k minus y. Already y is equal to k is there. Therefore, in place of y put k. K minus k is equal to 0. It means delta y is equal to 0. Means increment or decrement of the function y is equal to k. No. Therefore, delta y is equal to 0. It means y does not change. Okay, now we calculate delta y by delta x. Therefore, dividing equation by delta x both sides. Then delta y by delta x is equal to 0 by delta x is equal to 0. Taking limit as delta x tends to 0 means delta x made sufficiently small. Therefore, we are taking limit as delta x tends to 0. Therefore, limit as delta x tends to 0, delta y by delta x is equal to result 0. Already we know that limit as delta x tends to 0, delta y by delta x is equal to dy by dx is equal to 0, or dy dx of y is equal to 0, or dy dx of k is equal to 0. It means derivative of any constant is equal to 0. Okay, then what about y is equal to k graph? Check it. Okay, this is graph about y is equal to constant function. In this is x-axis, this is y-axis. We choose the point on the y-axis. Now we choosing the point 3. Then the line passing through the point 3 and parallel to x-axis, then equation of that line or line is y is equal to 3. 3 is constant, therefore we denote that is by k. Draw the tangent to the curve at any point on this line. Is must and should parallel to x-axis. Means the slope of the tangent parallel to x-axis is equal to 0. Derivative of any constant is equal to 0. Now discuss about one more example. Find the derivative of the function y is equal to x to the power n from first principle. Using first principle, y is equal to x to the power 1 means f of x is equal to x to the power n. Already we know that first principle, that is dy by dx is equal to limit as delta x tends to 0 f of x plus delta x minus f of x whole divided by delta x. Okay, in this result we put limit as delta x tends to 0 f of x plus delta x. Look here, f of x is x to the power 1. Now we consider x plus delta x is total term is x. Then f of x is x to the power n. According to that, this becomes f of x plus delta x is x plus delta x to the power n minus f of x. Already f of x result is there, that is x to the power n whole divided by delta x. Now as delta x tends to 0, according to concept, limit as delta x tends to 0 means as delta x tends to 0, then x plus delta x tends to x. As delta x tends to 0, the value of delta x is near to 0, then x plus delta x tends to x. Okay, now put limit as delta x tends to 0 means x plus delta x tends to x. Therefore, in place of x we use, in place of delta x we use x plus delta x tends to x and x plus delta x to the power n take as it is minus x to the power n take as it is divided by delta x is written as x plus delta x minus x. Look here. Here denominator delta x is there. Here also x plus x. Suppose cancel it. Denominator is only delta x. But written as in place of delta x, we use the x plus delta x minus x. This helps. This step helps. Another one formula. Already we know that in the concept of limit, that is limit as x tends to a, x to the power n minus a to the power n divided by x minus a is equal to n into a to the power n minus 1. Look here. Limit as x tends to a. Here x plus delta x tends to x. X to the power n. Here x plus delta x to the power n. Minus a to the power n. Here x to the power n. Divided by x minus a. X plus delta x minus x. So that delta x is represented as x plus delta x minus x. Okay. According to this result, the continue part of the this concept becomes n into a to the power n minus 1 means here n is always here also n. In place of a, x is there. Therefore, this result is equal to n into x to the power n minus 1. dy by dx is equal to n into x to the power n minus 1. Means derivative of the function x to the power n. Using first principle, we get the result dy by dx is equal to n into x to the power n minus 1. Okay. Now we check this result with one example. We are already taking one of the beginning problem, that is derivative of the function y is equal to x square plus 1 at point x is equal to 1 is 2. Means derivative of the y is equal to x square plus 1 at point x is equal to 1, that is equal to 2. Already geometrical meaning also we are already studied. Now check this result. Means graph is y is equal to x square plus 1. Y is equal to x square plus 1. dy by dx is equal to x square, derivative of x square. Okay, derivative of x to the power n. Derivative of x to the power n is n into x to the power n minus 1. N into x to the power n minus 1. Here n is 2. 2 into x to the power 2 minus 1 plus derivative of any constant is equal to 0. Already we know that derivative of any constant is equal to 0. Therefore, result is 2 into x to the power 2 minus 1 means x to the power 1, that is represent as only x. Therefore, dy by dx is equal to 2. Now check the point dy by dx at point x is equal to 1. When x is equal to 1, then 2 into in place of x put 1, that is equal to 2. Yes, this is already we know that the derivative of the function y is equal to x square plus 1 at point x is equal to 1. This is very simply solve or simply finding the derivative of the function y is equal to x square plus 1 using first principle. Result becomes very simplest form. This is the actual meaning of derivative. Okay, Thank you very much.